Okay, when we left off, we had spoken about powers of 10, and we figured out that, to cut right to the chase, that if we wanted to express something in what we call scientific notation, then what we were going to do is we were going to take whatever the number was, and we were going to move the decimal point until we had one non-zero value to the left of the decimal point. And each time we moved the decimal point to the left, we increased the power of 10 by 1. So the example I used was 456.8. The decimal point was between the 6 and the 8. We moved it 2 places to the left, which gave us 4.568. And we moved it 2 places, so the power of 10 became 10 to the positive 2. And we said if we move the decimal point to the left, the power of 10 is positive. If you move the decimal point to the right, the power of 10 was negative. And then we did a couple of examples. We went through that very quickly. And then we talked about metric prefixes, and we talked about engineering notation. And we said we were going to use a symbol to represent powers of 10 that are multiples of 3. Okay, so we were going to look at, we don't care where the decimal point, well, we do care, but we're not going to hold to that one value to the left of the decimal point. So we talked about a couple of the common engineering prefixes like kilo, mega, and giga. And we talked about some of the small values, milli, micro, nano, pico. We did a couple of examples. So we said that if we had 22 meg, the meg is a representative times 10 to the 6th. Meg is 10 to the 6th. So this is 22 times 10 to the 6th. If we had micro, we had 2.8 microamps. We get rid of the micro, we replace it with 10 to the negative 6. We had 47 pico. Pico is 10 to the minus 12th. So we had 47 times 10 to the minus 12th. And at that point, we said the next thing we were going to talk about was getting or swapping between units. If I had kilo ohms, how do I go to mega ohms, and so on and so forth. So to do that, let me share the next screen. And that screen is this one. So what we want to do is convert between different prefixes. So let me do an example and then we'll go through the steps. Well, let me do the steps first. First thing we're going to do, we're going to replace the prefixes with the powers of 10. The next thing we're going to do is we're going to determine if you are going to a larger or smaller power of 10. Let me ask this very quickly. Did Professor Atwood do this with you yet?
Oh, no, he said he wanted to leave it for you.
Okay. All right. And then if you are going to a larger power of 10, move the decimal point left. Easy way to remember it. Larger starts with an L, left starts with an L. And then we're going to move the decimal point the number of places equal to the difference between the two powers. I'll give you a minute to jot down notes and then I'll do an example. So let's say we had 47 K ohms we want to convert 47 K ohms to mega ohms. All right. So I would write this out as 47 K ohms equals blank mega ohms. First thing we're going to do is get rid of the prefixes and put in powers of 10. So that's step one. Step two, we're going to a larger prefix. So 10 to the 6th is larger than 10 to the 3rd, which means we're going to move the decimal point left. All right, we're going to 10 to the 6th from 10 to the 3rd. So we're moving to a larger power of 10. So larger, we move left. All right, and then 6 minus 3 is 3. So we're going to move the decimal point 3 places. Okay. So that means that we had 47 times 10 to the third ohms. We're going to put in the 47 with the decimal point over here, except we just figured out we have to move it 3 places to the left. So if I move the decimal point 1, 2, I have to put in a leading 0. That's where the decimal point goes. So that means that 47, and we can now put back in the prefixes, k ohms is equal to 0.047 megohms. Everybody with me? Questions?
Nope.
Okay, so the key thing was we look at the prefix here, we look at the prefix here, we're going to this side. So we want to look at this prefix and ask, is this prefix bigger than the one we started with? If it is, we move left. If it's not, we move right. How far do we move? We just take the larger minus the smaller. That tells you how many places to move. And it doesn't matter, we don't have signs, we just take whichever is the bigger prefix minus the smaller prefix to figure out how many places. The direction is determined by if we're moving to a larger or a smaller prefix. Let me do another example. We want to convert 320 microamps to milliamps. First step is we write down 320, we just write it out, 320 microamps equals blank milliamps. Next step is get rid of the prefixes. 320 times 10 to the minus 6 amps is how many times 10 to the minus 3 amps? We're going to 10 to the minus 3 is larger than 10 to the minus 6. Therefore, we move left. And if I take minus 3 minus 6, we end up with, actually, if we just do this as magnitudes, 3 places is what we're going to move. We don't care about sign in this. We just need to know how many places. So the difference between the two is 3. So we're going to move 3 places to the left. So again, we've determined it's to the left and it's 3 places. So if I go back over here, I have 320 times 10 to the minus 6 amps We're going to put in the 320 just like it is. All right, now we're ready to move the decimal point. The decimal point is here. And we said we're going to move left 3 places. So if I do that, I'm moving 1, 2, 3 places. That puts a decimal point there. Always put in a leading 0 in front of the decimal point so there's no confusion. Now we can get rid of the metric.
Sorry.
Yeah, go ahead.
Sorry, Professor. You have 320 times 10 to the minus 6. Is 320 times 10 to the minus 6 again? Or is that supposed to be minus 3 over there?
Thank you.
No problem.
Ten to the minus 3. So now we're going to get rid of the metric prefixes. 320 minus 6 is micro, is equal to 0.320 milliamps. What about if I had convert 22 microfarads to picofarads. We have 22 micro is times 10 to the minus 6 farads. And we want to know what that is in times 10 to the minus 12th farads. So we look at this, and are we going to a larger power of 10 or smaller power of 10?
Smaller.
Yeah, so 10 to the
We're
minus
moving right.
12th is smaller than 10 to the minus 6, which means we move right. And if I take the magnitude of minus 12 minus the magnitude of minus 6, we get 6 places. So that means we're going to move 6 places to the right. So if I put that in, I'm going to put my 22 in. And we're going to move, the decimal point is here, so I'm going to move 1, 2, 3, 4, 5, 6. So we could write that 22 microfarads is equal to 22 million picofarads. Everybody following the process?
Yep.
Any questions on the process?
Yep.
All right,
Nope.
let me say this. After a while, I mean, once you've been working with this for a while, it's going to be automatic. I mean, you're just going to sit there and go, 4.7 megohms is 4,700 k ohms. You're just going to do it. But at some point, you got to learn the steps. And what I would do is go through this process. It's a pain in the neck to write stuff out. There's going to be a couple of things in this course that you're going to sit there and go, this is a pain in the neck to do this. Why can't I just whatever method, okay? especially at the beginning, I would recommend you follow the process, because what you'll find is that if you start to take shortcuts now, you make mistakes. Not only that, but if in this particular case, if I saw, this followed by this, followed by this, followed by this, followed by that, if there was a mistake over here, and let's say, somewhere along the line here, you came up with 320 microfarads, microamps equals 32 milliamps. If this was right and this was right and this is wrong, you knew what you were doing, but just made a silly error. And on an exam or a quiz, I could give you partial credit. If you just said, oh, I know how to do this, and wrote down 320 microamps equals 32 milliamps, and if that's all you wrote, I got nothing to go by. I got no way of giving you any sort of partial credit. So, especially on quizzes and exams, follow the process. Show me formula substitution result if it's a calculation problem. Show me the steps if it's something like this. Because what I'm trying to do is get you to understand how to do stuff and work on it from there. All right, so let's do this. I said I was going to give you some homework to do. Let's do one or two of these first, and then we'll go into some homework problems. Oh, implicit in this, and let me put this right up before I even do a problem. Get rid of this. Couple of things, if we're going to have any sort of a conversation, everybody has to be on the same page. There's certain things you have to know, and that's the units for current, voltage, and resistance, the designators, the definitions. So in other words, what is current? What is voltage? What is resistance? We define those. What are the designators for current? And what's the units that currents are measured in? What's the designator for voltage, and what is it measured in? What's the designator for resistance, and what is it measured in? And the other thing you're going to have to remember or memorize between now and then is common metric prefixes for gig, meg, K, kilo, milli, micro, nano, and pico. Those are the ones we commonly use. So those are the ones you're going to have to know. So there'll be a quiz on that. No calculations in terms of none of the stuff we're doing today, but the definitions and the prefixes will be on the quiz. All right.
So basically, you're gonna say you'll have G equals, and then you'll want us to write giga.
Yeah, or I might give you. It'll be multiple choice, so it might be the metric prefix for 10 to the third is, and I'll give you the options. Okay.
How will we submit this quiz?
It'll be online. So what I'll do is on
Okay.
Thursday at the start of class, I will email you a link to the quiz. The quiz is an online
Okay.
quiz, and we all do it at the same time in class. Okay.
Okay.
Okay. If I didn't say that, I know I would forget before the end of class. I'll probably try and remember to send out an email as well. So let's see. Convert. Try those two. How many people are done? I guess you can click on raise your hand. Oh, give me a clue. Or physically.
Yeah, I'm done.
I'm done too.
Okay, we'll give it a couple more minutes because some people look like they're still working.
You purposely didn't put a metric prefix in number 1, right?
That's correct. Sort of the trick question.
Gotcha.
All right, let's take a look at them and see how you made out. So we want to have 0.02 amperes is how many milliamperes? Right-hand side's easy. Some number times 10 to the minus 3 amperes. So over here, we've multiplied by 1/1000th. What have we multiplied this thing by, 0.02 by, to get amperes? This is times what in here without changing the value?
Like times 10 to the 0.
Times 10 to the 0, all right? This would be multiplying by 1. So this over here, if there's no prefix, you're always going to put in times 10 to the 0 and the units. Okay? So from this, we see that first, -3 is smaller than 10 to the 0. 10 to the -3 is smaller than 10 to the 0. Which means I've got a short space here, so I'm gonna run out of room. We're moving right. And if I take the difference between 0 minus a -3, we're gonna move right 3 places. So if I put this in here, 0.02, we're going to move 1, 2, 3. We need to put a filler 0 in, and the decimal point goes there. So that means that 0.02 amperes is equal to 20 milliamps. Questions on that one? The tricky part was you had to recognize that with no space, with no prefix between the value and the unit, the metric power of 10 or the power of 10 is going to be 10 to the 0. Okay. Questions?
No. Also, because 10 to the 0 equals like 1, so you would be timing it by itself.
Yep, we're timesing it by 1, which doesn't change the value. Okay. If I had 47 nanofarads, and I want to know how many picofarads that is, 47 times 10 to the minus 9th farads is how many times 10 to the minus 12th farads? And again, 10 to the minus 12th is less than 10 to the minus 9. So that means we're going right. Minus 9 to minus 12 is again 3 places. So if I put in my 47 over here, and the decimal point moves 1, 2, 3 places, we got to put in the filler zeros. We can say that 47 nanofarads is equal to 47,000 picofarads. Okay. All right, we good? Questions?
Would you ever say 40,000 K picofarads, or would you just say
No.
47?
It would always, no, you can't have, you don't want to put two metric prefix. That's a good question. You don't want to put the two metric prefixes in. So this would be written as 47,000 picofarads.
Okay.
Probably, and again, we wouldn't really use it this way. We would go for nanofarads, or the other alternative to this would be 0.047 microfarads.
Mm.
Okay, let's do a couple of homework problems.
Can I ask a question too? How do you know you're moving right or left? Like,
how do you
when
know?
Yeah.
You have to look at the prefix you're going to and the prefix you're coming from. If the prefix you're going to is larger, you move left. If it's smaller, you move right. The easy way to remember it is larger moves left. And if you think about it, larger and left both start with an L. So
Okay.
if the power you're going to is larger, you move the decimal point left.
Okay.
You go
Thank
by
you.
the difference between the two.
Thank you.
Let me say this about the textbook. I reached out to the department. The secretary was totally blown away because she knows that stuff went over there in August. She doesn't know why it didn't, or it showed up as being non-assigned. So hopefully that'll happen quickly. She sent an email, copied me on an email that she sent to the bookstore that pretty much said, you know, this was sent in July. How come it's not ready? And she also relisted what was supposed to be there for the two courses. So hopefully they'll get that stuff in soon. What I didn't check was is whether or not there's a section under Atwood's name for this group, and if he had the textbook, but he should be teaching the lab section, so I don't think that he should have come into the picture at all, but I didn't check that.
He doesn't have any required programs on there. It would say, like, for yours before, it would say, oh, you know, we're waiting to get information. But for his, it says no required course materials. Also, it was updated.
Okay.
So
All right.
whatever the book is, it's there.
Okay, so the bottom line is that, you know, I did look into it and they're working on it, and hopefully they'll let us know when this stuff is in, so you don't have to check periodically. But I will again reach out to the department, the secretary and the department chair this afternoon to see if there's anything that comes in, and if they've heard anything, and to let me know when they hear anything. Okay.
Just one question.
Yeah.
Sorry, just for one question. And like, I don't know about anybody else, but in my other classes where we had a textbook, it took them a while to send us the access code for whatever it is or however it's going to work for this textbook. So are we going to just have to wait until we get the access code, or like, what are we going to do moving forward, or will you just like let us know?
All right. So what I'm going to do is, as soon as I find out that they are definitely ordering this stuff, as far as the problem for me is assigning homework. So as I mentioned last class, as soon as they tell us that they're ordering the books for you, I will copy the homework problems. That doesn't help you in terms of the reading stuff, but at least you'll have the homework problems that you can do. And like I said, I have no problem doing that, knowing that they're getting the textbooks for you. I just would not normally photocopy or make copies of homework problems and give them out if you were not getting the textbook, you know, in other words. So the publishers and the authors are going to get paid for the textbook, so I got no problem giving you the sheets with the problems on them. So, but for now, what we'll do today is I'll give you some of the typical problems that are in the book, and we'll do them. So what I'll do is let me get a new sheet. File, new sheet. And let's look at some of the homework problems.
Wait, Professor.
Yeah.
We didn't have any
is a
homework though.
Yeah,
No,
we don't have any homework.
We didn't have homework because of the issue with the
Yeah.
textbook. But what I'm going to do is I'm going to put some problems up that are out of the back of the book.
Oh, okay.
So this is homework for the next class.
Now we're going to do
Not
it as a problem
homework
session.
that's supposed to be taken.
We're going to do it right now
Okay.
as a problem session. I'd rather do it now, and that way, if there are questions, we can answer them right away instead of waiting till Thursday. Somebody else had a question.
Yeah, I did. Is the bookstore open? Like if I go there?
No.
No, I think you have to
No?
make an appointment or whatever. I'm not
No,
sure.
it's because
exactly.
I got an email saying that my book is ready to pick up and I have to call them to see what hours they're open. But I've been spam calling for the past week and no one answers. So it's because I need a textbook for another class and now I need it for this class. So I don't even know.
I don't know.
They don't answer.
I don't know anything about the bookstore. Anybody else manage to get a hold of the bookstore at all?
Yeah, you have to.
Mm-mm.
Wait, who said, yeah, you have to?
Me, Jancy, you have to email them. That's how I got in contact.
Oh, okay.
I-
So try emailing them, and I'll let you guys figure that out after class. And that way you can touch base with each other, or else actually, Jancy, if you have that email address and that, send it to me and I'll send it out to the class. Or is it online somewhere? Is it on the college website?
Let me take a look. I think I have it.
Or just mail it to me and I'll send it to the class and they can bombard the bookstore with questions. Okay, so I guess it would be better if we didn't do chapter 2. If we did chapter 1, it would work better. Okay, so let's try some near the beginning. Let's see.
What is the exponent of 3b?
Pardon me?
The exponent, yeah, what is that number?
10 to the ninth, negative ninth.
Okay.
Try those, and then we'll go over them in a minute. Take a couple of minutes and see about that. Okay, so if we want to look at something in scientific notation, we know, whoa, we don't want to do that. We've got 75,000, and we want to express it in scientific notation. So the rule for scientific notation was that we want to end up with one non-zero value to the left of the decimal point. So the decimal point wants to be there. Right now, the decimal point is here. So we're going to move it 1, 2, 3, 4 places. So we end up with 7.5 times 10. We moved it 4 places. And just like we said before, if you're going to a larger exponent, you move the decimal point left. That can also be said the other way. If I move the decimal point to the left, I'm going to end up with a larger power of 10. So right now,
Could you again, please?
say that again.
Could you repeat that rule again, please? You want the decimal point to have one number.
Oh
to-
yeah. So in
Can you repeat?
scientific notation, the rule for scientific notation is we have one non-zero value to the left of the decimal point. Okay, so that's when I look at the 75,000, that's telling me the decimal point has to end up between the 7 and the 5. That's where we're going to end up if we're in scientific notation. Okay. So scientific notation would say it's 7.5 times 10 to the 4th. It's 10 to the positive 4th because we moved the decimal point to the left. Remember, with no power of 10 here, the power of 10 is essentially 0. For engineering notation, the rule isn't as much about where the decimal point ends up with regard to the numbers as the fact that we want to move it in multiples of 3 spaces. So if I talked about 75,000, and we try and generally, as a rule, end up with a number greater than 1. So the decimal point is here. So if I go 1, 2, 3, so that's 3 places. If I tried to move another 3, it'd have a leading 0. So I wouldn't want to do that. So I would write that as 75.000 times 10 to the 3rd. All right. So in engineering notation, what we're looking for is this thing to be a multiple of 3. In scientific notation, we're looking for one non-zero value to the left of the decimal point. Okay?
What, I have
Questions?
a question.
Yeah.
Whatever you 75.000, What if you wrote just 75 times 10 to the third is wrong, right?
When you've got a situation like this, you can always get into the gray area of is or are the 3 zeros placeholders, at which point 75 is the value, or are they actual values? And that, just looking at a number, you can't tell. If I had something, in other words, if I had something like 75,462, I know that all of those are values. So if I was going to write this, I would write it as 75.462 times 10 to the third, because these are not just placeholders, they're actually values. When you write something like this, it's not clear what the level of accuracy is in terms of, are these placeholders or is it exactly 75,000? All right, and just looking at the problem, you can't. If I gave you something like this, I would have accepted 75 times 10 to the third, because you don't know. If I gave you something like this and you wrote it as 75 times 10 to the third, then it would be wrong, because you've lost the value of the 0.462. Does that clear it up a little bit?
Yeah.
Okay. All right. If we look at the next one.
Wait, on that one, I wrote K, so would you mark that wrong?
Oh, no. You could have written this as 75K, because K is 10 to the third. Yep. Okay. If I look at the second one, 0.0002, I want to end up with the decimal point. Here's my first non-zero value as I move to the right. So I want to end up with the decimal point there. So to do that, I have to move the decimal point 1, 2, 3, 4 places. So I know that I'm going to end up with 2 times 10 and a 4 up here. But the question is it positive 4 or negative 4? We said the rule is, if you're moving the decimal point to the left, it's making the power of 10 larger. I moved the decimal point to the right, so it's making the power of 10 smaller. So this is 10 to the negative 4. Everybody with me?
Mm-hmm.
If I look at the next one, in engineering notation, I want to look for a multiple of 3. So I could move it 1, 2, 3, and write it as 0.2 times 10 to the negative 3. Or if I want to end up with a positive value, I mean a whole number value, I could have written this as 1, 2, 3, 4, 5, 6, put the decimal point there and put in 2 filler zeros. So that would be 200 times 10 to the negative 6, because I moved the decimal point 6 places. Whether you write it as 0.2 times 10 to the negative third or 200 times 10 to the negative sixth, they're both equal. A lot of times that comes into play is, what are you going to do with it? So in other words, we talked about Ohm's law the other day. So if I had, this was a current, and this would be 200 microamps. And if I was multiplying that by mega ohms, I might want to put it in the negative 6, because we're going to see 10 to the negative 6 times 10 to the plus 6 cancels each other out. And we can ignore the powers of 10. So if I had it as milliamps, 0.2 milliamps times mega ohms, then I got to put powers of 10 into my calculations. And we'll talk about that more when we actually do calculations, but whether we write it this way or this way sometimes has to do with what we're doing with the number. And
I
again,
remember you saying that you wanted it to be more than one. Like
generally as a rule, you'd like it to be more than one if you're writing it out. But as I said, sometimes, and again, this will make more sense when we get into the next chapter, sometimes I might want to have a power of 10 that matches something else in the problem so I can eliminate powers of 10. And if the answer comes out to be less than 1, like in this case 0.2, that's fine. All right. If I just said to you convert it, I would probably look for the one that's greater than 1. So the 200 times 10 to the negative 6th. And again, don't worry about, for now, don't worry about the multiplying part. You'll see that, and I'll explain it again when we get to chapter 2, and we're using it in Ohm's law.
Would you repeat that last bit when you said sometimes you might want to have, because I got logged off and then logged back on? I don't know why. But...
Okay, so what I said was, in this particular example, let's say, actually, let me give it this example. This would be the preferred method because I've got a number greater than 1 for the number part. But this is 10 to the minus 3. Let's say that's 0.2 milliamps. If I was, let's say, doing an Ohm's law problem, and I want to take the 0.2 milliamps and multiply it by a resistance. If that resistance is in K ohms, 10 to the plus 3 for the K ohms, and 10 to the minus 3 for the milliamps, when I multiply them, are going to cancel each other out. And I wouldn't have to worry about either of the power of 10s in the problem. If I left this as 10 to the minus 6 and K ohms, then I would have to put it into my calculator as part of the calculations. And again, having said that, that will make more sense when we get to chapter 2 and we start using Ohm's law.
Okay.
Okay?
Okay.
Okay. Let's look at this one. We have 2 times 10 to the 5th, and we want to express it as a regular number. So we want to get this 10 to the 5th, get down to 10 to the 0. So we're going to want to move 5 places. We want to end up at 10 to the 0, which is less than 10 to the 5th. So that equals what? Times 10 to the 0. So which way am I going to move the decimal point?
Left, to the right.
Yeah, to the right.
To the right. So I got 2, and I'm going to a smaller value. Larger is left, so smaller is right. And how many places?
5.
5. So we got the decimal points right to the right of the 2. So I'm going to put in, we're going to move the decimal point 1, 2, 3, 4, 5. So we're going to put in 1, 2, 3, 4, 5 filler zeros.
Oh, would you have to put it? I just put 200,000. Would I have to do 200,000 times into the?
So as a regular decimal number, this is what we're going to get to a regular decimal number. So as a regular decimal number, it's 200,000.
Oh, okay.
Okay. But I wrote it this way so we could figure out, we know this is 10 to the 0, so it helps us figure out, are we moving to the right or to the left, and how many places are we moving?
Okay.
Okay. So if I look at this one, I have 5.4 times 10 to the negative 9. And I want to know what that is as a regular decimal. So that's 10 to the 0. So which way am I moving the decimal point?
Left.
Left.
And times to the left.
Yeah, I've got 0 is bigger than negative 9. So that means I'm going to a larger power of 10. So I moved left, and from 0 to 9, negative or positive, is 9 spaces. So I'm going to move 9 places to the left. So now I got my 5.4. I'm going to move 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my decimal point. So we're going to end up with 2, 3, 4, 5, 6, 7, 8, 9. So my answer when I get rid of the times 10 to the 0 is going to be the leading 0 before the decimal point. What is that? 8, 1, 2, 3, 4, 5, 6, 7, 8, 5. Okay. Questions?
I have a question for number 2. I put 20 milli. That's okay, right?
20 milli?
Yeah,
No.
like for the engineering notation.
The engineering notation, this one here is either 0.2 milli or 200 micro.
Oh, okay, yeah, I see. Yeah,
Yeah, it wouldn't be 20 milli. It would be 0.2 milli.
yeah.
Okay.
Okay, yeah.
Other questions? Okay. We're just about out of time. We are out of time. So what we'll do is next class, we'll actually move into chapter 2 and start looking at some circuits, and you'll actually see where some of this stuff gets used when we start talking about Ohm's law and why the powers of 10 in the engineering notation work out for us, okay? So between now and then, I'll try and figure out what's going on with the bookstore, and we'll see you on Thursday. And I don't know what, did
one more
Professor
thing.
Atwood say anything about what lab you're doing on Thursday? Did Professor Atwood mention what lab you're doing on Thursday at all?
No, today we have a lab.
We're doing soldering, and then we're also going to check like a car battery, but I don't know if that's for the lab for this class or if that's there's like 112 and 110. So I don't know which is which, but at some point during this week we're doing the battery, and at another point we're doing soldering.
Okay. Soldering is probably 110. The battery is probably, measuring the battery voltage is probably 112, this course. Okay.
Okay, sounds right.
All right. So see you all on Thursday.
All right.
Remember that Thursday, let me find the sheet. Thursday, we got the quiz on definitions and memorization of the prefixes. So don't forget that.
Yep.
All right.
All right. Bye.
All right. See you on Thursday.
See you.
Take care.
Bye.